All right, we're looking at more law of signs problems here, and these are going to involve what the textbook calls ambiguous cases. There are times with the law of signs where when you set it up beautifully and you solve it correctly, and you have no errors in your written work, sometimes the triangle just doesn't work, where the triangle blows up, or sometimes you have multiple answers for the triangles or for your angles, and that's what we're going to look at here, those crazy ambiguous cases, which kind of muddy the water with the law of signs. So let's look at this problem. We are going to solve this using the law of signs. If you notice, like when you do law of signs, remember you set up an angle with the opposite side. So I have 21 degrees and 3. So I'll say we have the sine of 21 degrees all over 3. Needs to equal, and then looking at my other stuff, I have x and 6. So it's going to be sine of x over 6. And one thing you need to remember is if you ever write sine, cosine, or tangent, or any other trig function, if you ever write any of those, you have to put an angle inside. You cannot do sine of a side length. So please don't say sine of 6 over x or sine of 3 over 21. You cannot do sine, cosine, or tangent of a side length. It must be an angle. So make sure that you set it up right, because that's fairly important. And solving this, we're going to cross multiply, which we have talked about in our class a little bit. Some of you strangers on the internet may not have done it yet, but I'm going to pause this and solve this equation by cross multiplying. Now I've gotten this far. I wanted to show you what I've done so far. I simply cross multiplied 6 sine 21 and 3 sine x, and then I divided by 3, and I got sine x equals this stuff. The way you separate sine from the angle is you do the inverse sine of the other side. So x is going to be the inverse sine of all of that information right there. So the inverse sine of 6 sine 21 degrees over 3, and we will throw that in the calculator, which I'm going to pause the video while I do that, and that will give us our answer. All right, there we go. So I punched that in, and I got x to be 45.786 degrees, and that would be our answer. Now, whenever you're doing the law of signs, you always want to make sure your answer makes sense. 3 is smaller than 6, so the opposite angle from 3 should be smaller than x, and I got 45 for x, so it checks out, and I'm happy with this answer. One thing you need to make sure with your calculator is that you are in degree mode. If you are not in degree mode, notice mine says DEG right there. If you're not in degree mode, then you're going to get a radian answer, which is going to really be wrong because these triangles just work better with degrees. So anyway, so I get 45.786. Now where this problem gets interesting is whenever you're doing law of sines problems or law of cosines or anything that involves shapes out of the textbook, pay attention to the labeled dimensions. The 6, the 3, and the 21 degrees were all given to you, which means those are written in stone. They cannot change. Now, x wasn't given. You had to solve for that. So x has a little bit of flexibility. That's why we call it a variable. And what happens with this triangle is we actually have more than one possible answer for x. And to try to show you why, I've got this little illustration right here, and it's color-coded. But the things that must be true in this triangle, this is the same triangle we just solved, is that the blue side length of 6, the red side length of 3, and this green angle of 21, those have to remain those dimensions. They cannot change. Everything else can change a little bit. And that means what I could do is I could maybe grab this end of the side length of 3 and bring it up a little bit. Like I could bring it up there. Now the problem with that, I'm going to move the 3 out of the way, is that while I do still have a side length of 3, a side length of 6, and an angle of 21, I've blown up this triangle. It's no longer connected. So I've got to somehow manipulate this where I still have a triangle. And to do that, I'm going to bring my 3 back down. This is the triangle we just solved. We have a nice triangle with 3, 6, and 21. But if I keep bringing this side length of 3 around, now it's remaining the same length. The side length of 3 hasn't changed. I could bring that side length all the way around to here and actually create a second triangle like this. And notice I still have that same given information true. I still have the side length of 3, I still have a side length of 6, and I still have an angle of 21, And ooh, that green arc got kind of silly. Didn't see that coming. Anyway, so this side length, this angle is 21, the side is 3, the side is 6. All of that is still the same, but this time x is a much larger angle. So what we have to do now is find out the second possible answer for 6. Solve for x, not solve for 6. So we need to find that second possible angle for x, and that's what we're going to do right here. So we have another possible triangle where everything is still the same. We still have 21, 6, and 3, only now x is a large angle, and the way you get that second angle for x, it's real simple. The only problem is you have to remember to do it, is you take your original answer and you subtract it from 180 degrees. So I'll do 180 degrees minus 45.786 degrees, and we get an angle of 134.214. And that's our other possible angle for x. And I'm always checking to make sure it makes sense. 3 is smaller than 6, so x needs to be larger than 21. And 134 is larger than 21, so I'm happy with that answer. Your calculator will always give you the small angle first, because if you remember, when you do an inverse sine, we did the inverse sine of something, inverse sine always answers on the right side of the circle, which will not include angles like 134. That's way over here. So you have to find the obtuse angles yourself. The calculator will always give you an acute angle, and this triangle just happens to have 2 answers, and that's kind of the stuff we're going to be looking at in this lesson. So let's see. Let's move on. When do you consider the possibility of multiple triangles, or when do we have these weird ambiguous cases? You have to be aware of it when you start with a side-side angle triangle. If two sides and an angle are given, which is what happened here, I gave you 2 sides, 6 and 3, and an angle, you'd have to consider a second possible triangle. Or another way of thinking about it, these two things are kind of saying the same thing. If you use the law of sines to solve for an angle, which is exactly what we did, we solved for the angle x by using the law of sines. So since I solved for an angle with the law of sines, we had to consider the second possibility. Get the second triangle by subtracting your first angle from 180, and always make sure your answer makes sense. Go back and look at the angles and look at the side lengths, and remember the larger side lengths must be opposite the larger angles. And that's something you always want to be aware of, because sometimes, even though your work is good, your answers don't make sense. So let's work a few problems, solving for x, y, and z in the following triangles, and I do want to solve for all of them. Let's set up law of sines. Let's see what we can do with this one. Let's see. I see 42 and 9. Those are given angles. That's a given angle and side length. And so I'm going to use sine of 42 and 9 as much as I can, because those two things were given to you. The other one I'm going to have to solve for now, since I was given 7, I'm going to have to solve for its opposite angle of x. So let's set that equal to sine of x over 7. And I'm going to pause this and solve that real quickly. Alright, so I solved that and ended up doing the inverse sine of all of that. I got x to be 31.361 degrees, and then I'm going to check and make sure that that makes sense. If x is 31, let's see, 31 degrees is smaller than 42, so opposite 31 is 7, which is smaller than the side opposite 42, so I'm happy with this answer. Now, I did start, and maybe we need to note this at the very beginning of the problem, the given information was 2 sides and an angle. This is a side-side angle triangle, which means we need to consider a second possible answer for x. So x could also be 180 degrees minus that answer, 31.361. And if you punch that in, 180 minus 31.361, you get 148.639. We get 148.639. And what we end up seeing here is that will not work, because 148 is larger than 42, but my answer needs to be smaller. So we would actually throw that one out because it's too big. And the only answer for x that we need to go with is 31.361. Now, once I do get x, I do want to solve for y and z. So I now need to solve for y and z based off that x. I would solve for y next. So to solve for y, I would do, I would say that y that's going to be the easiest one because I can simply do 180 degrees minus the given angle of 42 minus the answer for x we just solved. And we get y to be, let me punch that in real quick. There it is. So I get y to be, am I in pin mode? Nope, I'm not. There we go. So I get y to be 106.639, and that is an angle. And I'm going to make sure that, well, we don't really know if it makes sense yet because we haven't solved for z. So I got y to be 107-ish, and I'm just making a little note to myself there. So y is about 107. So I expect z to be something huge. And also, I am going to have to use y to solve for z. I'm going to have to do sine of that angle over z. So if you notice right here, I did store this for y in my calculator. So when I work this out, I can simply recall this exact answer for y by hitting the y button. So now we need to solve for z, and the way we're going to solve for z, let me scroll down a little bit, is I'll do sine of 107. So my z is going to be sine of 107, not 107, it's 106.639 over the opposite side of z is equal to, and I'm going to stick with 42 and 9. You want to use as much given information as you can, so sine of 42 over 9, and then we'll cross multiply and solve that equation. There we go. So I punched that in, and I got my answer for z to be 12.887. And that does make sense because 12 would be the longest side length, and it is opposite the largest angle. 7 is the shortest side length, and it was opposite the smallest angle. So I'm happy with this x, y, and z. And as you can see, you have a lot of work on these problems. Please circle your answers or do something to kind of set them off so when I'm checking work, I can easily tell where your answers are. So there we go. Kind of a beast of a problem, but that's how that one works. Let's look at another problem. Let's see. Let's try this one. Solving for x, y, and z again. Let's see which one we can solve for. I have to use 95 and 4 because those are opposite each other. So sine of 95 over 4. Then it looks like I'm going to have to solve for x first again because it is opposite the given side length of 12. And notice I do have 12, 4, and 95. That is an SSA triangle. So we will need to consider two possible triangles. So sine of 95 over 4 is equal to sine of x over 12. And we will solve this triangle. I'm going to pause this while I work it out. All right, here we go. This problem did something very interesting. I cross-multiplied, and I divided by the 4, and I ended up doing the inverse sine of all of this stuff. And my calculator returned undefined. It says some kind of error message. First, whenever you get an error message, double-check to make sure you plugged everything in correctly, because you could very easily have accidentally hit maybe a 2 instead of a 12. Maybe you just missed the 1 when you punched in 12 sine 95. So make sure it's punched in correctly, and I'm looking at that. It's inverse sine of 12 sine 95 over 4. That's correct. And then look back and make sure, just do a quick spot check, make sure your cross multiplying was good. It was 12 sine 95. That's what I had. 4 sine x. That's what I had. I divided by 4. And everything looks good. So I've double-checked my work to make sure I punched everything in correctly, and I did, and I still got an undefined answer. What that means is that this triangle is impossible with the dimensions that were given. So you can write impossible triangle, you can say no solution, anything along those lines, but this triangle is impossible. And if you look at the dimensions, maybe we can see why. Look at what's given. We have a side length, the things that were given were this side length of 12, this angle of 95, and 95 is a big angle, and that's pretty much drawn to scale. That looks about like a 95-degree angle, that side length of 12. But if you look at my other side length of 4, if this thing is supposed to be 12, a side length of 4 is not that long. I did not draw this to scale at all. A side length of 4 would be 1/3 of this. So 4, whoa, that's not what I wanted to do. 4 would look more like this length, about like that. So if I were drawing this side length of 4 to scale, it would actually look more like that length right there. It wouldn't be as long as I drew it, and this side length would never actually connect. That's not long enough to finish drawing this triangle. So if I have these dimensions as they're drawn, the triangle is actually impossible, and you get a no solution. Doesn't mean you did it wrong, but you do need to double check your work, and it just turns out this is an impossible triangle. Okay, so that is one of the ambiguous cases. The next one, and this is the last problem I wanted to do, is this problem. So we're going to set up and solve this one. We will do sine of x over 10 and sine of 36 over 7. Those are the opposite sides. So I'm going to pause this and set it up and get the ball rolling. All right. So there's my setup. I did 36 over 7 and sine x over 10, and I'm about to cross multiply. All right, so there I finished solving it. Cross multiplied, I did the inverse sine, and I got 57.108, and I'm double checking this, and 57, if this is an angle of 57 degrees, that does make sense. 10 is larger than 7, so this angle opposite 10 is larger than the opposite angle opposite 7, so I'm happy with that. However, once again, this was a side-side-side triangle, or side-side angle triangle, which means I need to consider a second possible answer for x. So x could be 57.108, or we can subtract that from 180 to get a second possible answer for x. So x could be 57, or x could be 122.892. So I subtracted from 180, and an angle of 122, well, let me think about that one. Does 122 make sense? 122 is larger than 36. The angle opposite 122 is larger than the side opposites match up. So even though 122 is a really big angle, the how much larger doesn't play in. All that matters is 122 is larger than 36 and 10 is larger than 7. So in this case, both possible angles work, and we will stick with both angles. Now here's the tricky part. When you're solving this, if there is a second possible triangle, what we'll do with that second possible triangle is we'll actually just kind of put this on the back burner. So we'll put this on hold, and we will come back and solve this one later. And these problems are a hassle. I'm going to put this on hold. And what I would actually do if I were y'all is I would copy this answer and the triangle onto another sheet of paper, and we'll come back and solve it in a minute. So let me pause while I do that. There we go. So what I've done is I've just put this off to the side. And I'm going to ignore the 122.892 for now. We'll come back to that. And right now, I'm going to solve the triangle with 57.108. And what I've actually done, I do have it copied up here in the corner, just kind of show that it's in the back of my mind. But I do have it saved on the next page. And the problem with this is now we actually have two triangles, and we have to solve for y and z twice. So based on x being 57.108, I'm going to take that, and I'm going to solve for y. So y, we will simply subtract from 180, so let me do that. All right, so I got y to be 86, and I'm going to change this right here, because I'm solving this triangle with x being 57. And since y was 86, that's my largest side. When I solve for z, I expect that's my largest angle, so z should be a very large side length. I'm going to pause and set up for z with the law of sines. There we go. So I set up law of sines. I cross multiplied and solved for z, and I got 11.892. And 11.892 makes sense because that's my largest side. My smallest angle was 36, and my smallest side was 7. So everything matches up with this triangle. Now that I solved for that one, remember there was a second possible angle answer for x, and that was 122.892. So now we start over, and we go and we solve this second possible triangle, and I'm going to do that right here. And so now I'm going to solve again, but now x is something different. So when I solve for y in this triangle, I'm going to have 180 minus 36 minus that answer for x. And I'll punch that in, and I'm going to get a different answer for y. All right, and I got 21.108. Now, don't let the scale throw you off. I know that doesn't look like a 21-degree angle. This does not look like a 23-degree angle. But these are going to end up working right. Generally, you don't trust the scale or how the picture looks. You go with the math, not the way it appears. So now that I have y to be 21, I'm going to set up the law of sines, and I'm thinking ahead. Y is my smallest angle, so z should be my shortest side. And that's what I'm going to look for when I set up and solve for z. There we go. So I set up, I cross-multiplied, and I punched all of this in the calculator. I got z to be 4.3-ish. And so I'll look at that. 4.3 is my smallest side. It is opposite the smallest angle. 123 was my largest angle. It is opposite my largest side. So that checks out. And this is one of those pesky triangles where they both are correct answers. And I do expect you to give me both correct answers. So we have this triangle where x was the small angle. Then we have this triangle based off the same information, but x was a larger angle. And that's one of the things that really drives people crazy with the law of sines. But you do need to consider all of those possibilities, and we'll hammer this out some a little bit later.